All right, welcome back, everyone. Today we're going to talk about absolute value equations and absolute value inequalities. So in this section, we're just going to talk about how to solve absolute value equations and how to solve inequalities. So an absolute value equation is just an equation that contains an absolute value. To solve these equations, you want to follow these steps. We want to first isolate the absolute value, get it on one side of the equation by itself. We're then going to use that to write two equations. The first equation is exactly what you see, except without the absolute value sign. And then the second is the same as the first, except we change the sign after the equals. And then we solve both equations. So let's try some examples. We have the absolute value of 3x plus 2 is equal to 1. We have the absolute value isolated, and so we want to write two equations. The first equation is exactly what we see without the absolute value. And the second is the same, except after the equal sign, we change the sign. So positive 1 becomes negative. Now we have two equations to solve. Subtract 2 from both sides. We get 3x is equal to negative 1. Divide by 3, and you get x equals negative 1/3. Subtract 2 from both sides, you get 3x equals negative 3. Divide by 3, and you get x equals negative 1. And so those are our two solutions. Now we have x, the absolute value of x plus 2, minus 5 equals 9. First, we want to get the absolute value by itself. So we'll just add 5 to both sides. We get the absolute value of x plus 2 is equal to 14. Now that we have the absolute value isolated, we can write two equations. The first one is exactly what you see without the absolute value. And for the second one, we just switch the sign so that it becomes negative 14. If we solve both equations, we get x equals 12. And x equals negative 16. So absolute value inequalities are pretty much the same as equations, except for a couple of little differences. We still want to isolate the absolute value first and write two equations. The only difference is with the second equation, in addition to making the sign negative, you want to flip the inequality. We're then going to solve the equations, and then we have to determine the solutions, depending on whether it's an and or an or problem. So, writing the answer for the absolute value inequalities is usually the troublesome part. In general, solving the problem is easy. It's writing the answers that tend to be a problem. So a helpful hint to remember is that if you have something in an absolute value which is greater than a number or greater than or equal to a number, you're going to treat that like an or problem. Any part of the lines that are shaded at the end will be part of your answer. If you have an absolute value less than a number, or less than or equal to a number, you're going to treat that like an and problem. And in that case, you're looking for where do the lines overlap. If you can't remember how to deal with and or problems, refer back to section 1.6. So let's try some examples of these. We want to solve this and write our answer in interval notation. And what we have is the absolute value of x is greater than or equal to 2. So, the absolute value is isolated. We want to write two equations. The first equation is what we see without the absolute value. So x is greater than or equal to 2. The second equation, we're going to flip the inequality and change the sign. So not only does it become negative, the inequality flips as well. And so now we have two solutions we want to graph on a number line. And so the first one, x is greater than or equal to 2. And the second one, x is less than or equal to negative 2. Remember what I said on the previous slide? If we have an absolute value greater than a number, we treat it like an OR problem. And so any part of this line that's shaded is part of our answer. And so if we want to write this in interval notation, we're going to get minus infinity to negative 2 with a bracket, and then a union to infinity. And remember that the union, the little u, there's just a symbol there to connect those two sets of numbers. It just says that those two sets are 1. So now we have the absolute value of 2x plus 1 over 3 is less than 5. The absolute value is isolated, so let's write two equations. The first equation, 2x plus 1 over 3 is less than 5. And the second equation, 2x plus 1 over 3 is greater than negative 5. And so the first step on both of these would just be to multiply both sides by 3 to get rid of the fraction. Here we're going to get 2x plus 1 is less than 15. And here we're going to get 2x plus 1 is greater than negative 15. And now we can solve both of these equations, subtract 1 from both sides, divide by 2. We get x is less than 7. Here we subtract 1 from both sides, divide by 2, and we get x is greater than or negative 8. And so now let's just go to the next page, and we're going to put both of these on a number line. The first one we have is x is less than 7. And so here's 7 and everything less than 7. The second we have was x is greater than negative 8. Negative 8 and everything greater than negative 8. And if you go back and look at the original problem, it was absolute value less than a number. And so because it was less than, we're going to treat this like an AND problem. And only the parts that overlap are part of our answer. And so we're going to get negative 8 to 7. And that would be our solution set. Finally, let's try one more example. And this is a very quick example. Here we have the absolute value of 2x minus 4 is less than negative 5. Now, although this looks like the other problems that we've worked, there's one major difference. We have an absolute value that's less than a negative number. The definition of absolute value is that absolute value is always a positive number. So, there's never a time when the left-hand side under that absolute value is less than 0. And so there's no way it can ever be less than negative 5. This side is always positive. And because that side is always positive, it'll never be less than a negative. And so the answer to this problem, without even doing any work, no solution. Absolute value can never be less than or equal to a negative number. And so at the end of this lesson, you should be able to solve absolute value equations and solve absolute value inequalities.